Have you ever found yourself staring at a confusing error message in Haskell, wondering what went wrong? It can be really frustrating, right? If that's you, then you're in the right place. Today, we're diving into the issue of rigid type variables in Haskell and how to resolve it. I totally get it. Haskell's type system can be tricky, and encountering errors like this can leave you feeling stuck. You're not alone in this. Many developers face similar challenges when working with Haskell's type variables. Let's take a closer look at the specific issue at hand. One user recently asked, "Why am I getting a rigid type variable error in my Haskell code?" They shared a snippet that includes a data type, a class, and an instance, but they're running into a type mismatch error. Sound familiar? Let's break it down together. So, what does this error mean? The message indicates that Haskell is expecting a type variable, but it found a specific type instead. This often happens when the type variable is too rigid, meaning it can't be matched with the expected type. We'll explore how to fix this step by step. And stick around. At the end of this video, I'll share a pro tip that will help you avoid these types of errors in the future. To address the user's issue, we need to understand the concept of rigid type variables in Haskell. The user has defined a function called bar that takes a string and returns a type A. However, A is a rigid type variable, meaning it cannot change based on the input. Next, the user is trying to match the string type A to the type A. This is where the type system raises an error because A is not specifically defined as type A. We need to adjust the function to handle this correctly. To fix this, the user can create a pattern match for the string input. This means defining how the function should behave based on the input string, allowing it to return the correct type. Finally, the user should ensure that the function's signature reflects the specific type being returned. This will help avoid confusion and ensure that the type system can correctly infer the types. Fun fact, Haskell is known for its strong type system, which can catch many errors at compile time. It's like having a superpower that helps you write safer code. Now let's look at the answers provided by other users. This user suggests that the issue arises because the type variable A is expected to be any type, but the function returns a specific type, type A. They propose a solution using existential quantification or by extending the class to include a new function, foo, which maps a string to the specific type. When calling the bar function with the string type A, it will correctly return the type A instance. Here's the pro tip I promised. Always ensure that your type signatures align with your function implementations. This practice can save you a lot of headaches down the line. And there you have it. You've learned how to tackle rigid type variable errors in Haskell. Remember, understanding type systems is key to becoming a better programmer. If you found this video helpful, hit that subscribe button for more tips, and don't miss our next video where we dive deeper into Haskell's type system.